Like all things that are array-based replication offloads all of the hard work of replication from the host, the CPU and the RAM-intensive operations. However, array-based replication on its own, without any additional host or application integration software, does not provide application consistency, meaning that the data at our remote site isn't guaranteed to be consistent, or in other words, not guaranteed to be in a state where you can easily recover your applications from, and that's far from ideal. So, if you do use array-based replication in its vanilla form like this, when you come to restart your applications from these replica volumes, you may have some cleanup prep work to do before your application will start, and it's things like replaying logs and the likes. Now then, array-based replication can be integrated with applications, and it can therefore be made application aware, meaning that the remote replications are application consistent. For example, Microsoft Exchange Server offers a way to plug in array-based replication engines with the native Microsoft Exchange Server replication engine, meaning that the application's native replication engine manages the replication and the application consistency, but the array does the heavy lifting of moving the data over the network. Array-based replication often requires a fiber channel replication network, but not always. However, they do tend to offer a really comprehensive list of replication options, including both synchronous and asynchronous options, as well as the more complex site redundancy options, such as the 3-site option we highlighted on the previous slide. Finally, array-based replication can sometimes be expensive, depending on your array vendor and your platform. Now for a bit of application-based replication. This time there's no array doing the heavy legwork. The entire burden of replication falls squarely on the shoulders of the app server. Host CPU, RAM and network are all called into action to make the replication work. And when we say host network, this tends to be an IP network. But of much bigger importance is that application-based replication, by its very nature, is application consistent. Obviously, the application has intimate knowledge of itself, meaning that the way in which it replicates data is perfect for it to be able to recover from. It would be a pretty stupid application that created replica copies of itself that it couldn't painlessly recover itself from. And on this point, application-based replication technologies also perform things like data integrity checks as part of the replication process. Anyway, all of this is really important if you ever have to use it in anger. Now then, a popular form of application-based replication is log shipping, so let's have a bit of a closer look at how that works. We'll start out with our production site hosting the active instance of our database. Now let's add our disaster recovery site and a replication link between the two sites. During normal operation, the active database at our production site on the left ships its logs over to the standby database instance. And by the term shipping, we mean it transmits them over the network between the two sites. Once received at the remote standby database server, these logs are then replayed into the database, creating effectively a remote copy of the production database. Simple as that. And major technologies such as Oracle DataGuard and Microsoft Exchange Server and SQL Server all have native application-based replication technologies that work on the log shipping principle, in the process creating transactionally consistent replicas. Now let's cover off a couple of concepts that are integral to replication technologies, as well as the wider business continuity plan, which, if we remember back to the beginning of the lesson, is the bigger picture.